In this video tutorial, we are going to talk about graphs, the graphs module. And we have set up a torus in the 3D module with a velocity field that goes linear with distance. It renders as a torus as expected, and in the PV diagram it looks like a straight line with some increased emission at the tips. We can open the graphs module by clicking on the icon at the top in the toolbar, or if it's not there yet, we can open the desktop and then use the graphs icon there, pin it to the top toolbar and then click on it. It starts with an empty graph displayed, and we have a selection of graphs at the top from which we can choose. Each has some specialization. Particles, crisscross maps, hydro quantities or field quantities. And we can also start with a blank one where we can add data from. And then we can do operations like clearing the graph, fitting functions, operate between different data sets, and we can replot our graphs. If we render, our graphs get replotted again, and we start now with the connected graph. As an example, we select that graph, and best to rename it right away, give it a sensible name so we can distinguish it more easily if we have more than one graph. Let's call this line profile from a PV diagram, which is what we're going to do as an example. We look at the type tab in the parameters area, and here we can select from a variety of plot types like spectrum, pixel intensity, optical depth, and so on. But we're going to select PV, which generates a line profile from the PV diagram as it has been rendered before. Let's look again at the rendering in grayscale. It basically flattens the PV diagram along the slit direction from top to bottom and adds all the emission. So we get a double peaked line profile with a certain width in kilometers per second, and the pixel intensity in this case is arbitrary. The units are arbitrary because we are rendering with the basic renderer and we're not looking at any particular physical units. Okay, and then we can manage the data in the data tab. Right now we have only the model data. We click on that, and then we can change the name, for example. And we can choose between different plot types like scatter, combined, line, and points, or change the color. However, we'll stick to black for our model data and to connect it. And there are more options here: make it visible, invisible, change the point size if we have points. In this case we don't, but the line thickness, for example. And we can work with the scales, say multiply or do other operations to our data output. And normalize, for example. Right now we have up to about 3000 values, and if we rescale or scale with the button at the top, then we get a normalized profile. We will have a look at the other parameters later on in a different tutorial. Let's stick with the basics right now. Okay, we would like to compare this model with other data, observed data, for example. Then we go back to the data tab and add a data set. Then we get a new data dialog. We can choose from 3 different kinds of new data sets, like points, for example. In this case we're going to choose points, and then change our name to observations, change the color, and then go down to the data points, edit data points button, and here we can load the data. We can also type in data from scratch one by one by clicking on the add data point button and put these values in, which are updated right away. We get a blue point, which is at the position that we are setting. And so on, we can go on and add more and more data points. So our graph builds up. But this is not what we're going to do. We're going to import an existing data set, which is an observed torus data set. Presumably, we have generated this earlier on with a slightly different torus. And we can choose from how we have to read these values, the x, which column is used for the x and y value. If we have error bars, we can include those and click on import. Then our data are in our graph. Okay, we can actually change these values individually if we need to for some reason. And now we can reset our range so we can compare. But it's best to compare this kind of data if they are normalized, so we can have better reference, since our units are arbitrary in this case. So let's normalize. We have to click normalize for each data set, and then go and reset our graph scale. Now we can easily compare them. And now we can go on and adjust our model if we like to. We go to our torus and change, for example, the velocity, and then render. Now something happens that might be unexpected. At the beginning we have changed our model name, or the name of our model dataset. But the model is always written to the same name set, or the set that is named model data. So if we want to continue changing our data, our model, we should not change the name of our dataset. So we have deleted it. You can recover from that by renaming your old dataset to model data. Say this is useful in case you want to keep a model output and you just change the name, and then call it something else. Change your model slightly. Go back and render. So now your data set is new and different, and you can normalize it to compare with the others. We now rename our old dataset if we think that was better, and then re-render. It will be rendered into this dataset. Okay, so you can go on and adjust your model, play around. And here are some properties for the graph where you can do operations with the graph points if you like. You can grab points and move them. Zoom in and out to have a look at the details. You can use the mouse wheel to zoom in and out too. And you can pan your graph with one of the buttons. Now let's say you're happy with it. Then you can right click on the graph and save the image. Select save the image, and then you can name it. Select a location on your disk and click save. Then your image will be a PNG file or whatever extension you gave to it with a certain format. If you don't like that format, you can resave with a different width and height in dimensions. Right now, Shape only saves image files. You cannot save them as vector graphs. Now we have a better format for publication. You can increase the quality such that it's publication quality. You can improve the looking of the graph, some aspects, change the fonts or change the size of the font. Change the format of the numbers and so on. Change the margins. So you can customize the graph to what your needs. You can change the position of the labels from right to left, or the bottom to the bottom. Now they overlap with the numbers, so the margins that we chose weren't very useful. Okay, let's say we are happy with that, and we can resave it, of course. If you actually need vector graphics, then you can output the data by clicking on the data points edit button and save these data. You can do this for each of the data sets, which can then be combined again in an external program such as GNUplot or similar. Okay, thank you very much.